It has taken years of experimentation to develop the proper design for a truly bimodal means of transporting goods from shipper to receiver. One leader of the technology is the Thrall Car Manufacturing Company, which produces the Roadrailer. Over 1,500 Roadrailer units are now in service, of which 250 have been in use for 8 years. These units have operated through all types of climate and terrain, traveling at 80 miles per hour on railroads and at 65 miles per hour on highways, carrying high-value auto parts and other commodities. It's hard to imagine the smoothness and ease of handling experienced by a mainline engineer.
Companies won't have to maintain big yards right there. They won't have to have them. They can have a couple of tracks. You can pull your Roadrailer trains in there, cut them off, truck it, take them right up and spot them at the dock. It's going to be a big money saver for the companies and everybody else. And for me, it's an awful good train to run. Oh, yeah. It's just like running a passenger train. Man, it gets right up there and comes right down. When you want to stop her, she'll stop. When you want her to go, she'll go. This Roadrailer is better than a passenger train because you don't have to stop the passengers. And you don't have to worry about spilling their coffee cups either.
In the near future, you may be on a crew that will have a train of bimodal freight units. Others of you may be called on to assist when one of these trains experiences a problem while en route. Roadrailer is a new concept, which is proving to be a very efficient way of transporting goods from one location to another. The products are loaded onto a trailer that is capable of operating on the rails or on the highways of our nation. An air suspension system in both highway and rail service provides a smooth ride, but also facilitates transfer from one mode to the other. They have a uniquely designed coupler mechanism which is slack-free. This eliminates in-train impacts due to slack action during normal operations. For enhanced safety, a special wrench must be used to operate the coupler, and a horn will sound if an unsafe coupler condition exists. Roadrailers have a unique rail brake system that utilizes a standard ABDW control valve in conjunction with a specially designed R7 control valve. This system develops a constant braking rate, regardless of load, providing predictable stops in shorter distances than conventional freight trains. One additional feature is an onboard system which detects hot boxes and low air pressure and then applies the brakes automatically. Because there is a major difference between the couplers on a locomotive and the Roadrailer units, an adapter car is used to interface the two systems. The adapter car has a normal freight car coupling system on the end that connects to the locomotive, and a special yoke-type coupler on the other end that connects to the Roadrailer units. This adapter railer also contains air regulators and valves that are used to supply needed air pressure for the operation of the Roadrailer units. This adapter car is connected to the locomotive's main reservoir equalizing pipe, and its reservoirs are regulated at 120 pounds per square inch. A Roadrailer train can be rapidly assembled by placing individual units on the track, one at a time. The rail wheels are lowered to the rail as the highway air springs deflate. The rail bogie is unlocked, and the highway wheels are raised as the rail air springs are inflated. Finally, the bumper pin snaps in place. This is accomplished through operation of the mode selector valve. First, the selector valve is moved from highway to transfer position by the use of a special tool. This deflates the highway air springs. Moving the selector valve from transfer to rail position unlocks the rail bogie and inflates the rail air springs. Both the brake pipe and the rail supply line are 7/8 of an inch high-pressure flexible hoses and are connected between units by quick disconnect couplings. The couplings are arranged so that the hoses cannot be reversed or cross-connected. The brake pipe works just as in conventional railroad equipment. The engine man calls for a brake application by reducing brake pipe pressure and a brake release by restoring this pressure to its normal state of 90 pounds per square inch. The rail supply line is used to supply the rail suspension reservoir and the braking system on each unit. Protection devices prevent charging of the brake pipe until the rail supply line is charged above 85 pounds per square inch. Do not open the locomotive brake pipe angle cock until the rail supply line gauge on the adapter car reads at least 100 pounds per square inch. The R7 control unit receives the brake cylinder pilot signal from the ABDW control valve and supplies a load-weighted brake cylinder pressure in response to this output. The R7 unit detects low rail reservoir pressure. Any pressure below 85 pounds per square inch applies emergency brakes on the train by venting the brake pipe. This feature prevents a dragging spring brake, a severe leak, a broken rail reservoir line, or a broken rail supply line from going undetected and causing hazardous operating conditions. It also detects emergency brake applications, provides an automatic parking brake, and ensures that rail brakes are released whenever the highway supply line is pressurized by a truck tractor. The Roadrailer is equipped with one tread brake actuator per wheel, which applies a standard composite brake shoe to each rail wheel. Each actuator utilizes a pneumatic brake cylinder and a mechanical spring brake combined in a single housing. The spring brake is held off the wheel by rail reservoir pressure above 58 pounds per square inch and applies only if pressure is lost. Sufficient force is developed by the spring brake to park a fully loaded Roadrailer should the rail reservoir leak down over a period of time. There is a rail suspension selector cock that permits the cutoff of supply air from the rail reservoir to the individual Roadrailer air suspension system should a piping failure occur, causing a serious leak. The rail reservoir selector cock permits the cutout of the individual reservoir. Turning this cock to the closed position does not drain the rail reservoir of pressure, but does prevent charging of the reservoir by the rail supply line. Closing this cock can disable the brake system and may cause the spring brakes to slowly apply. If it is necessary to run with the reservoir cut out, the brakes must be backed off by the slack adjusters. An ABDW cutout cock is used to isolate the valve from the brake pipe should malfunctions occur. Overheated Roadrailer journal bearings are not detected by wayside hotbox detectors due to their special rubber-isolated mounting. Located on each rail axle journal bearing adapter is a metal lug which transfers bearing heat to a hotbox detector consisting of a pipe fitting with a low melting point seal. Should either journal bearing seriously overheat, the metal seal will melt and blow out. Air will escape, and this will cause an emergency train brake application. There is a manually operated purge valve piped into the rail supply line that is used to exhaust the rail supply line and brake pipe when disassembling Roadrailer trains. This enables the hose fittings between cars to be easily disconnected and also sets the automatic parking brakes on a string of cars during disassembly. You will also find two cutout cocks that are normally open in rail operation. These are used to cut off brake pipe and/or rail supply lines. A normally closed, manually operated quick vent valve is provided to vent air from the air springs without causing retraction of the bumper pins. There is also a quick fill valve that supplies additional air pressure to the air springs for raising the car body. These valves are used during the coupling and uncoupling procedure. Now that we have seen some of the basic components that make up the Roadrailer units, let's take a look at some of the things that could go wrong. Most problems likely to be encountered en route will be related to automatic train brake applications due to the action of the protective features on board each Roadrailer. As a general rule, there are a number of conditions that are capable of activating the protective features in the air brake system that will cause an emergency brake application. A separation or failure of the brake pipe line. The separation or failure of the rail supply line. A loss of rail reservoir pressure on any Roadrailer or adapter railer, which may result from conditions such as overheated journal bearing, failure of any hose connected to the reservoir, or failed rail air spring on the adapter railer. If the train is stopped due to an emergency brake application, there are a number of steps that must be taken to determine the location of the failure. First, check your rail supply line pressure and brake pipe pressure at the rear of the train. A reading greater than 105 pounds per square inch indicates the rail supply line is in good condition. Then determine that the reservoir equalizing pipe angle cock on the locomotive and the adapter railer are open and the hoses are properly connected. Next, walk towards the rear of the train and check that hoses are securely connected between all cars and that no air is blowing from any part of the air system on any car. If replacement of the end hose is necessary, close the rail supply line or brake pipe cutout cocks on the affected car and the car ahead of it. Now, replace the damaged hose and reopen the cutout cocks. Check the brake cylinder push rod on either side of the car. As the reservoir on the car recharges, the outer chrome sleeve begins to retract. When it fully retracts, the main reservoir is charged to approximately 60 pounds per square inch. At this point, wait 2 minutes longer. The inner push rod will remain extended. Recharge the brake pipe. Check that the inner brake cylinder push rod retracts as the train brakes release during recharge. The train may now proceed, but make a note of the car number for repair. Should the ABDW control valve on any car malfunction, steps must be taken to isolate the valve from the brake pipe and release the individual car's brakes. Turn the ABDW cutout cock to the closed position. Then pull the reservoir release handle and hold it until the blow of air stops. Recharge the brake pipe and check the brake mechanism at the rail wheel to be sure that the brakes are released. A Roadrailer should be considered totally disabled if an unrepairable failure occurs in either the brake pipe or the rail supply line, which prevents maintaining air pressure in the train, or in the case of serious mechanical failure. In this case, the only option is to set out the affected car. Close the rail supply and brake pipe cutout cocks on the Roadrailer to be set out. The train will be cut just behind the affected car. Lower the landing gear on the car behind the affected unit until the red line is fully exposed. Push the purge valve handle on the car behind the unit to be set out. Hold the handle pushed in until the blow of air dies out. The brakes will apply on all cars behind the unit to be set out. Disconnect the brake pipe and rail supply line hoses between the unit to be set out and the unit behind it by using the quick disconnect fittings. The train may now be cut by uncoupling the car to be set out from the remaining cars. To operate the coupler, use the coupler wrench that is stored in the adapter railer. Insert the wrench into the guide tube and engage the coupler mechanism. A horn will sound as you pull the safety cable handle. Turn the wrench handle clockwise to open the coupler. Radio the engineer to pull forward 3 to 5 feet. When the cars are apart, close the coupler and remove the wrench. The forward portion of the train may now proceed at low speed to the nearest siding, where the bad order car can be set out. After the defective car is in place on the siding, lower the landing gear and push the purge valve, holding the handle until the blow of air dies. Disconnect the supply line hoses and uncouple the cars. The forward portion of the train may now return to pick up the units left behind. Recouple the train, connect the air supply lines, open all the necessary valves, and raise the landing gear on the car that was just coupled. Charge the train's air system, perform a departure brake test, and proceed in accordance with accepted operating procedures. Now, let's review the procedure for setting out a car. Close the brake pipe and rail supply line cutout cock on the car to be set out. Lower the landing gear on the car behind the affected unit. Push the purge valve handle on the car behind the unit to be set out until brakes are set. Disconnect the brake pipe and rail supply hoses between the affected car and the remaining portion of the train. Use the coupler wrench that is stored in the adapter car to uncouple units. Pull ahead several feet and remove the coupler wrench. After the defective car is placed on the siding, lower the landing gear and push the purge valve to set the brakes. Disconnect the supply line hoses on the defective car and uncouple the units using the coupler wrench. Now, recouple the train. Connect the brake pipe and rail supply hoses. Open the brake pipe and rail supply line cutout cocks. Raise the landing gear. Make an air test. proceed in accordance with accepted operating procedures. The Roadrailer units have proven themselves to be very reliable after several years of service, and will continue such service in future operations on our railroad. As with any new operation, it will require some adjustment on your part, and some familiarization as to the characteristics of these trains. Hopefully, this film has answered some of your questions about these trains, and you will be able to adjust, as you have with all new operating procedures.